Okay, so we're going to finish lab 24. We have done 3 tests so far, testing the pH of household chemicals using chemical indicators. We've done baking soda, vinegar, and we've done carbonated water, okay? All right, not that I'm trying to sell this brand. And now we're going to do sugar water, okay? Or a solution of sugar, okay, which has water in it, of course. So our chemical household name of water would be sugar. Okay. Now, in truth, okay, all right, this is sucrose, but just to simplify things, we're just going to give the formula of glucose. So we'll just say C6H12O6 because you see that formula in this Regents course a lot, okay? And of course, I already put the chemical name there, I'm sorry. So the chemical formula would be C6H12O6. I can read my own worksheet. I know, hate me forever. Okay, and we're gonna call this glucose, which is part of sucrose. Sucrose is really glucose and fructose bonded together in a disaccharide, but we're just gonna keep it glucose since this course pounds the idea of C6H12O6 like we saw in the form last night, okay? So I'm not truly lying because glucose is part of sucrose, but there is, of course, fructose in there too. But bottom line is you should be looking at this formula of C6H12O6 and recognizing that to be a carbohydrate, a sugar, okay? And that's important as we identify acid and bases here. So without further frost, what I'm gonna do here is I'm going to dissolve some sugar, okay, sucrose, and making some sugar water. Now, do you think sugar is polar or non-polar? If you've got carbons, hydrogens, and oxygens.
Non-polar. Polar.
Polar. That oxygen's in there is going to make it. So if it's polar, it's generally going to dissolve in water that is polar, as we learn, like dissolves like. Now, in truth, okay, the glucose, okay, in our sugar can hydrogen bond with itself, and therefore it can hydrogen bond with water. So the intermolecular attractions are similar. So I'm just going to dissolve this, okay, and I know it's kind of bright. If I pull this over, you can see that I'm dissolving the solution. So I've got sugar water, okay? And of course, I've got dissolved glucose and dissolved fructose. Okay, all I'm going to do now is pour them in to these smaller beakers, and we're going to run our test of 6 indicators to figure out what the pH of sugar water should be or will be based on our understanding of pH. Okay, and I'm going to level these out. Okay, it doesn't matter how much really. Okay, they're all the same concentration. Okay, so, and that's our Domino sugar. We're putting a plug in there for them. All right, now, let's go and using table M, which I put up here, I'll take this off when we do our analysis. Let's use methyl orange. So first test, methyl orange, okay? And so we know it's 3.1. and lower is red. Some people still have a tough time reading and understanding what this is, okay? 3.1 and lower means it's red. 4.4 higher is yellow. Any case, let's pour in some methyl orange. And we get a nice yellow color. What does this tell me? Oh, we need our what? We need our, yeah, can you get those, you can pass those out for me, Haley? The colored pencils. So we've got ourselves methyl orange test. We've got ourselves a yellow. Okay. So yellow, and color that in there. Now, what does that tell me? Well, that means it's 4.4 or higher in pH. Okay. So what would be our estimate there? if yellow color, when methyl orange, a chemical acid base indicator,
Above 4.4.
yeah, we'll say 4 point, greater than or equal to 4.4. Because 4.4 is the pH in which methyl orange will turn yellow, so it's greater or equal to. Okay, so bromothymol blue. Okay, let's do the next one. Okay, bromothymol blue. And we put this in here. Let it dissolve. And what color are we getting here?
Green.
Green. Okay, you might be colorblind like me. Okay, so this is a green color. Okay, now if it's a green color, let's go see bromothymol blue. There's a yellow. 6.0 and less is yellow, 7.6 and greater is blue, but this is green, so where would be the pH here?
The middle.
Yeah, so this would be, now, the middle would be between 6.0 and 7.6, so we have to put an estimate here.
Why couldn't it be like?
What was that? Yeah, it's in between 6.0 and 7.6, it's in the middle somewhere. So right now we know it's above 4, it's greater than 4.4, it's at least 6. And could be up to 7.5, I guess I should say. I should say 7.5, right? So I probably should say 6.1 to 7.5. Why am I changing that?
If it was on it, it would be yellow.
Yeah, exactly. So I have to be greater than 6.0, okay, and less than 7.6. So I changed it to 6.1 to 7.5. Okay, that's
This is
bromo.
green?
Yeah, and it's definitely green. Okay. Yes. Oh, I changed it because I know from here it says 6.0 to what? So it's yellow, turns yellow 6.0 and less. So that means anything above 6.0, okay? So I put 6.1, but I could do what? I could change it to greater than 6.0, but what? Less than 7.6. I could write it that way too. All right? Bottom line, it's green. It's a color in between. All right, so the next one is phenolphthalein. Okay, so phenolphthalein. Drops of Jupiter go in. And what's our color change? What's our phenolphthalein?
Clear.
It's colorless, right? So if it's colorless, it's what? It's got to be,
Less than 8.
yeah, so we would say less than or equal to 8, which kind of makes sense. If we're between 6.1 and 7.5, it should be less than 8. So that kind of confirms that. And this is colorless. Okay. Let's get old litmus going here. Litmus test is the fourth one. Yep. Okay, so number 4 is colorless. I'm sorry, number 3 was colorless. Number 4 test is litmus. I made some more. This litmus might be going bad. It's purple. Purple. Hey, so where's the purple color in litmus?
Middle.
Yeah, there's no red, there's no blue, so purple's in between red and blue. So what does this tell me? Well, it's greater than 4.5, but what? Less than 8.3. It's in between 4.5 and 8.3, which kind of confirms what we have here. Okay, so far, brome cressyl green. That's thymol. And brome cressyl green. Okay, that's going to be our 5th test. What color we got there? Blue, I think. I need help with the colors. I never was good with colors. In kindergarten, I think I failed my color test. Didn't recognize I was colorblind. Neither did they. Okay, so brome cressyl green test color. Oh, but this was purple. This was blue. Going to table M. Hey, blue is what? What does blue say? I am What does blue mean for Brome Cressel green?
Is this purple?
What does blue mean? Yeah, so it's going to be greater than or equal to 5.4. Let's do thymol blue.
What?
That's the last test.
I have a feeling this could be in the middle.
Bro, what are you doing? Bro, he like a serial killer.
He literally sounds like a psychopath. Sorry,
All right. So this is what?
Yellow.
Yellow. Which kind of makes sense because it's less than 8. Or 8 and less. So this means that we have an estimate of less than or equal to 8.0. And this was a yellow. So what would you say? We're going to round this to a whole number now. I'm going to take away table M good here.
Yummy.
Okay? So what are you going to say? What do you think the estimate is for the pH? We're going to do a whole number for sugar water. Based on everything you know.
Less
Well,
than 8.
it's less than 8. It's greater than 5.4. It's in between 4.5 and 8.3. It's less than 8 again.
6.1.
It's between 6.1 and 7.5. What did I add to these two things? Didn't I add water?
Yeah.
Does water have equal amounts of H3O pluses and OH minuses? It's neutral. And then I added sugar. Is sugar an acid or base?
No.
No. Sugar is not acidic nor basic. So would we expect this pH to be 7? And doesn't the test it doesn't confirm it definitely, but does this test support a 7?
Yeah.
Yes. So the pH, we're going to say the pH is equal to 7. Explain the reasoning. I think the best one that explains it would be the litmus and the bromothiamyl blue. Litmus did what? Litmus gave a color that was what?
Litmus was purple.
Yeah, litmus was purple, we'll say. That's a good. Was purple because why? Because
It's neutral.
pH of 7 is what?
Neutral.
Between the red acidic color and the what? And the blue basic color. And I think the other one that kind of gives it away is bromothiamyl blue. That's a big word there. Was green. Okay? At a pH equals 7.
What is the word after acid?
Color.
And what's it before?
Acidic.
No, like before acidic.
Red.
Oh.
Litmus was purple at a pH of 7, is between red color and blue. Bromothiamyl was green at a pH 7, which is between what, yellow for acid color and blue for the basic color. I'll read it again. Litmus was purple at 7, which is between red color and blue. Bromothiamyl was green at a pH of 7, which is between yellow and blue. Okay? What's the H plus concentration, or the H3O plus, if the pH is 7? 1 times 10 to the negative 7. What must the hydroxide be? Hey, this is neutral pH. Shouldn't they be equal? 1 times 10. If you forget that, A -7 plus a -7 is equal to that magic number, 10 to the -14. And of course, is this acid, acidic, basic, or neutral? Neutral, because it has a pH of 7, and that should help you with your form tonight. C6H12O6, not an acid, not a base. If it was, we would see color changes that are not in the middle of these scales, especially bromothionyl blue. Okay, so now we're almost done. Okay, let's go to the data page here now. All right, we did baking soda, household name baking soda. Chemical name was sodium hydrogen carbonate. Chemical formula was NaHCO3. What was our pH with this? What did we get for our pH? Look back on our. We're done with those tests. We did 4. We got 10. Thank you. What was the H plus ion concentration? 1 times 10 to the pH is 10. It's like 1 times 10 negative. The pH is 10. It's 1 times 10 to the negative. Yes. What's the other one? The hydroxide. Yes, because 10 plus 4 is 14, right? Okay, and was this acidic or basic? If the pH was 10.
Basic.
It was basic. We'll put a big B here. Okay. All right, if you can see that on there. All right, so the next one was vinegar or vinegar. I say vinegar because.
I like Vinegard.
Yep. Okay. Chemical name was acetic acid. Acetic acid. Chemical formula. Hydrogen acetate also would be HC2H3O2. Or we can write this one, CH3 Coo. You can write it in 2 forms. It's the Coo one. I want you to know the Coos are what? Acids. So like last night, who's an electrolyte? Acids, bases, and salts. Okay, what was the pH of this? Was it 3? What did you guys get for the pH of vinegar? What did we get together? 3, yeah. So what was that H plus ion concentration? 1 times 10 to the negative 3. What was the hydroxide then? 3 plus what is 14? 1 times 10 negative 11. And was acidic or basic?
Acidic.
It was acidic, below 7. Then yesterday, because you guys bought me some carbonated water, so this was, is that what we call it? Seltzer, yeah, I can do this. Seltzer. Seltzer water. What's the chemical name?
Is it break time yet?
No breakdown, because I'll give you, I'm gonna keep going because we get the video going. So seltzer water, we're gonna go to hydrogen carbonate. Hydrogen carbonate. You could use carbonic acid as well, doesn't matter. Chemical formula, H2, notice the H is in front, CO3. This pH was actually a 4, slightly higher, because of that green color that we got, I think, in brome crystal green. It was in between. H plus ion concentration, 1 times 10 to the what? Negative 4, what's the base? 1 times 10 to the 4 plus what is 14?
10.
And this is, of course, an acid below 7. This is the one we just did. This was sugar. Chemical name will say sucrose. But we were talking really about the glucose in sucrose. And we're going to use C6H12O6 so that you know that's a sugar. The pH of this was 7. What was the H plus ion concentration? 1 times 10 to the negative.
7.
And of course the hydroxide, 1 times 10 to the negative.
7.
Right, and this was?
Neutral.
Right. Boom, those are the 4 that we did. Okay. Let's move on to the conclusion question. We're going to skip that question on the bottom. And I think I only got this back page, yeah. Need about a little more minutes here. Okay, so based on that data we just collected, and I'll just have to get this off the screen. Okay. So based on this, okay, list the two chemicals out of the four that had the highest amount of hydroxides. No. Hydroxides are the OH minus. The most basic. Basic means hydroxide. Hydroxide's OH minus. So who had the highest pH?
Baking soda.
Baking soda. And then what was the next highest?
Sugar.
Sugar, water, right? So, sugar. Now we would say it's really the water, but you get the idea. Who had the highest concentration of hydronium? It sounds like hydroxide, but it's not. It's H3O+. So what am I really asking? Who was the most acidic? Vinegar, vinegar, and seltzer water. Which chemical tested would produce the lowest pH? Lowest pH, lowest number, most acidic. Vinegar or vinegar. You got me saying that now.
It's so fun.
It is. Okay, so now this is if a household chemical, all right, turns methyl orange yellow and bromothymol blue. Okay, so let's put this up here. I'm just putting my table M up here. Okay, if the household chemical turns methyl orange yellow, that means we're going 4.4 or higher. Bromothymol to blue, hey, that's what? 7.6 and higher. And thymol blue, oh, to blue as well. What is the approximate pH of this chemical? Hey, come on, pay attention. Methyl orange is going to yellow. That's 4.4 or higher. Bromothymol blue is going to blue. That's 7.6 and higher. Thymol blue is going to blue. 9.6 and higher.
Like 10.
10. It's a good number. Because they're all above 9.6. So it's approximate. So the pH is approximately 10. Could it be higher? Sure. All right. Now, based on number 2, which ions are the largest quantities? If we're going to say the pH is 10,
Acidic. Wait, no. Acidic.
oh, it's a pH is above 7.
Basic.
Basic.
So basic.
So OH minus. Circle it. Okay, which ions are smallest quantities? Yeah, we'll put these together, right? Because they're the one and the same. H plus and H3O plus. They're synonymous. Okay? And then which solution can be described? This can be described as what? If there's a lot. Basic, right. Okay? So, let's do the next part of this. We're almost done. And we have these. So number 3 says we have H3PO4, which is in, it's phosphoric acid. It's in a lot of soft drinks. Okay, so I'm gonna put this up here. All right, and let me just erase this. I'm gonna put up table M here, where it might be. So H3O4 is found in many soft cola drinks based on this chemical alone. What color would you expect? Now, what I'm really telling you is H3PO4. Do you think it's an acid, base, or neutral H3PO4? What is the distinguishing characteristic about this chemical as given to you? What is in front?
H.
H's. They're screaming to you that this gives off H's. All right, so it's an acid. So if we look at table good, okay? If we look at table M, okay, what do you think phenolphthalene's gonna do?
Less. It could be either.
Yesterday.
Oh, wait,
It was like a,
Well, if it's acidic,
Oh, less.
is it below, above 7, or at 7?
Below.
Below 7. So 8 and anything lower is colorless. So this would be what? Colorless. Right? Table M is telling me it's below 8. This is the colorless. Anything 8 and lower is colorless. What about litmus? Litmus. If this is acidic, below 7, it's going to be what?
Red.
Yeah, either red or purple, right? So we could say red or purple. Because if it's close, right? Thymol blue. Thymol blue,
Yellow.
it'd definitely be yellow because it's 8 and lower, and we know that we're below 7 if it's an acid, so this would definitely be yellow. Okay, I'll do the next one for number 4. Calcium hydroxide. What is this calcium hydroxide? Is it an acid base or a neutral compound like sugar? Calcium hydroxide. Yeah, and it's a base because, not just because you see OH, it's a base because you see a positive ion. And if you go to table K, or L, table L, it lists it as a base. So this means the pH is above 7 or below 7? If it's basic. Above, right. So phenolphthalein. What color do you think it is? It's 8 points. Anything above 9 is pink.
Pink.
So we're going to basically say pink. Could it be clear? A little bit sure. Litmus. Or above 7, generally speaking, will be what color?
Blue.
Blue. You guys, some of you guys are not paying attention. This could actually help you. Brome Cressel green.
Blue.
Blue because we're 5.5 or greater. That's the color that goes with this and greater. So it's blue. Okay? All right, so that's that. And then we got a little bit left and we're done. Write a balanced reaction between ammonia. Ammonia, although we didn't test it, is a base listed in table L. So NH3 is a base. Now you notice something, it doesn't have a hydroxide. NH3 is not an Arrhenius base. An Arrhenius base would have a hydroxide ion in it, okay? But this is one that's posted for you, so it must be a Bronston-Lowry with water. It's gonna make ammonia hydroxide, which means it's gonna make NH3. Well, let's think about this. If this is a base, does it accept a proton or does it give off a proton?
Accept.
Accept. So a proton is going to move this way, but a proton is an H+. So what does it become? NH4. And it gained a what? A positive, right? So it's NH4 plus. What happens to water? If water in the future, if it starts by giving,
HO.
it's going to be
Minus.
we'll say OH minus, right? Okay? And water is acting as a what? Bronston-Lowry,
Acid.
it's donating an acid, right? There's your base, and that's your acid. Identify all the acid bases and conjugate acid base pairs. We can just do it here. Base, acid, in the reverse. Well, OH minus becomes H2O, right? If OH minus becomes H2O, in the future it has one more H. How'd that happen?
It took it.
Yeah, wasn't there a delivering of an H?
Yeah.
So this is accepting an H plus.
It's a base.
So it's a base. And the one that's giving it or donating is a what? Acid. So you have the acid and bases. Let's write the conjugate pairs. What's a conjugate pair? This was last night. Same chemical. So I'm going to do one conjugate acid base
H3
pair.
and H4.
I'm going to start with H2O because I see the acid. H2O is the acid. Its base is OH minus. Of these two, which one's the acid? The one with the greater number of H's, NH4 plus, and its conjugate base is NH3. Okay, put your name on it, and you're done. For those at home, if you got to this point and you have the 4 tests done, you're done. If you're missing a test, you got to get that from somebody who was here for those tests. All right.